SQL on big data, SQL on Hadoop kind of technologies, right? With the clear differentiation that it can actually go beyond Hadoop, with the differentiation that you don't need to define schemas in Hive Metastore, but from a broader category perspective, I would put it under SQL on Hadoop.
Hawk is SQL on Hadoop too. Somebody was saying.
Yeah, I'm saying like at the category level at SQL on Hadoop, there are a bunch of technologies. There are probably like 50, 90 technologies that go into the SQL on Hadoop. So, but that's kind of the broader category.
So as a reference, you mentioned Impala, and Impala also works with Arcade.
Yeah.
Yes.
So
Right.
that would be a direct comparison for it.
That would be a direct comparison when it comes to performance.
Right.
Yeah.
So having looked at that before, they had done some benchmarking with traditional Hive queries versus using Impala because they did optimization on IO level. Have you done anything to compare the standard?
So we do a lot of internal kind of comparisons at this point. So mostly using TPCH and TPCDS benchmarks. Right, so the comparisons I would say is basically some queries are faster in Impala, some queries are faster in Drill. So that's kind of the phase. And the idea is basically to put out benchmarks. I think that again, from a performance standpoint, the direct comparison would be Impala.
Right.
When
one
you
other question, if you don't mind. So since you said it runs as well, it doesn't require MapReduce.
Yeah.
You're using Zoop, you can manage this at a scale-out level. Are you running it? Can you run it under Yarn then? If I'm managing, or you just relying on Zoop?
So it is not yet integrated with Yarn. So basically the way you would do it is you would allocate some resources for Yarn-based applications and you have to give some resources to Drill. So it's more static at this point, but there is work in progress to make it,
So if I have an existing Hadoop cluster with data, I wouldn't be able to run Drill.
So you just carve out some resources for Drill. So you allocate certain things to Yarn. The problem is, but at least we have seen in the internal kind of testing is that there is kind of an overhead in launching the containers with Yarn, which is not a, so the low latency application is not a solved problem with Yarn, right? So that needs to be first of all addressed before Drill can run in Yarn and still be able to manage good performance. So that's kind of the work in progress.
What about resource? Are you trying to integrate the plans to integrate resources?
What do you mean? Elaborate.
So are you trying to integrate Drill? Is there a way to launch Drill with resource cluster?
So there is no, I wouldn't say there is like a ready to go containers that you can launch, but I would think of it similar to any other application framework, right? From a Mesos management standpoint. Yeah.
So since it's ANSI SQL, you can do create table as select, right? So
Yeah.
and what is the output format? Do you specify that separately?
Yes. So when I do create table as, I'll try to show an example of that. So you can specify what is the storage format is going to be. So you can specify Drill can write Parquet files, Drill can write JSON files, Drill can write text files at this point. So yeah, so you can specify the storage format.
Just follow up on the questions about running on existing Hadoop type of frameworks such as Yarn.
Yeah.
And so, you mentioned Drill has been deployed on quite a number of sites, right? So what would be the typical characteristics of those sites? They're not really running, let's say, other people's distributions, right? They're running MapR.
Mainly MapR. I
Mainly
think a couple of probably Cloudera.
We
Okay.
can't just switch it back here.
Yeah, so he,
Down, speaking.
okay, I'll let you complete the question before
Okay.
I answer. Yeah.
Right, so imagine the following scenario. Well, let's say I'm on Cloudera side, okay. Already have CDHD deployed. And I found this wonderful technology called Drill. I really like it, I want to get it deployed. How would I do that?
So the question is, if I have other distribution, how do I deploy Drill? So deploying Drill on other distribution is no different from deploying Drill on MapR. In fact, there have been like no special optimizations done for MapR, right? So the thing is, Drill is an open source project. There are some ways to configure resources in Drill. So things like you can configure what is the memory that you can use, basically a couple of memory settings that you can use, that's something you can configure through Drill configurations. And whether you are running it on MapR cluster or Cloudera or any other cluster, basically you would carve out that specific resources for Drill, and then you manage your remaining part of the cluster with other resources. So because it's not integrated more static
So
partitioning.
it's coexisting with yarn, basically.
It will coexist, it has to, and that's the current situation.
Coexisting doesn't mean that it runs on yarn. Currently it just coexists.
It
Later
coexists,
later
yeah.
on it's going to run on yarn, sounds like, right?
Yes.
So, when that happens, do you anticipate, one will be able to manage drill through Cloudera Manager or Ambari, or not really?
So the question is, when Drill is integrated with Yarn, will it be able to manage through Cloudera Manager or Patternworks? I think managing Drill through Cloudera Manager or Patternworks has no specific dependency on Yarn. It's a matter of whether the distributions basically will support Drill. I think.
Yes, that's
right.
the question.
Yeah.
Wh-
So
were they?
I'm not sure.
Thank you.
I don't have the answer. There is nothing technically stops them from doing it, right? And this is kind of a more newer product in terms of the GA, so we just have to see. So moving on, so I'll try to do a quick demo or hopefully walk through the slides. We'll see how it goes. But a few things I want to show is just what does schema discovery on the fly mean, and a couple of ANSYS SQL queries, very simple. I'm not going into ANSYS SQL specifics here. And how do you manipulate? So what are some of the ANSYS SQL extensions that you have in Drill that can be used to manipulate complex data? And I'll try to do most of the queries here. Seems like a technical audience. I'll try to do from the command line interface, SQL line, but we'll wrap up with how do you connect to it from ODBC interface, Excel. And Drill Explorer is one of the interfaces that comes packaged with Drill ODBC driver. So I'll try to show that as well. So with that, let me go ahead and bring up command line. Can you see? Okay, so what I have here is basically I downloaded a tarval from the Apache Drill website and tarred it, right? And it created this directory for me. And I went to the bin, and there is basically a Drill embedded. So as I was saying, you can deploy Drill on a single node, just your local machine. You can launch it, or you can deploy it in a cluster mode, right? So for this demo purpose, all the initial part of the demo, I'll just do it from a local mode, where I try to access some of the local kind of file system queries. So let me actually introduce you kind of to the data set that I'm going to use for queries. There is no way you can see this. Okay, so the names of the data sets is, there is a business data set, it's basically all business reviews. So, so the idea is basically it has a bunch of fields. It has some simple fields like business ID and what is the review count of the business. And then there are some complex fields like what are the hours during which the business is open, what are the categories under which the business is listed. So this is the public data set I'm just using for the demo purpose here. So that's the business, right? So business information in L. And then the second data set is the reviews data set. So it has things like, again, it is a mixture of simple and complex types. So it has things like who is the user who did this review, what is the review ID, what is the star rating he gave, what is the date of the review, how many people rated this review as cool, funny, useful. So there is some kind of, again, mixed complex and simple data. Right, so let's start with this. There is another data set, but I'll talk about it when we get to it. So going back to the command line here. Okay, so the first thing you would do, so the particular application that I launched is called SQL Line. It's a JDBC application that comes packaged with Drill. So the first thing I want to do is just I'm interacting with the database here. So the first thing I will do is show schemas, right? And as we talked about, Drill schemas can be Hive databases. They could be HBase namespaces. In this example, I'm just querying the local file system. So what I have here is few workspaces, right? So the DFS essentially is pointing to my local file system. I'll show the configuration later. But the DFS essentially is my local file system. Default is pointing to one directory. Root is pointing to one directory on my local file system. Temp is pointing to one directory on my local file system. And all my business and the reviews data set, I put in a directory L. And I just created a kind of a logical workspace name for it, right? So it's basically a file system with a bunch of directories. So what I can do here is, so let's try to do a few queries here.
Sorry, what is the CP.db?
So this is another out-of-box kind of name workspace that comes with Drill. So whatever there is in your class path, basically this is mostly for testing purposes. So all the directories that you have in your class path, So when you're querying file system, you are literally kind of pointing to a file system. It could be local MapR or Hadoop or S3 file system, and each of the things represent here a directory, right? It's a logical name for that particular file system. So
This is a directory within the Hadoop system.
this is a directory in this case. It could be a directory in the Hadoop file system, but in this case, it's just on the local file system for now.
What is the significance of that? It's kind of metastore for drill or something?
Sorry?
What is the significance of cp.default? Is it kind of a metastore for?
Yeah, so the cp dot I would just actually ignore. The cp dot default is mainly created for testing purposes. So as part of QA, basically you want to keep a bunch of JSON files in different locations, and you don't want to keep creating kind of workspaces for each of the locations. So you would identify that as a class path. Everything in my class path directories, identify that as cp. That's all.
How
Right?
did you create dfs.yam? How did that?
So you have, so let me actually show this. So there is a drill UI. There's a drill UI. So you can launch that on all the drill bits that are running. And this is the place, simple UI, to kind of create the storage plugins, update the storage plugins. And one of the storage plugins is DFS, right? And in this case, actually this is launching another instance. That's why you are seeing MapR file system instead of my local file system. But the idea is that this could be a local file system, it could be a S3 file system, and under that you just create workspaces. So there is a root workspace, there is a clicks workspace, so basically just pointing to a directory on that particular file system. Right? It's a logical way to reference it. Go ahead.
Yeah, well, you mentioned you referenced class path. Is there any dependency at all on Java for this?
Sorry?
You made reference to class path. I'm just curious if there's any dependency at all on Java.
No dependency at all. Yeah, you can just remove that workspace and no issues. Okay, so I don't think this is a perfect way to see it, but we'll go through more interesting examples, specific examples. But all I'm trying to do here is basically select start, right, from a JSON file on my machine. Go ahead.
So you knew that that business.json existed. Is there some way to query for the tables that you could look at?
You can do show files.
Gotcha.
So there is a command called show files. So you point to a workspace and then you say show files, right? It could be huge, so you have to be careful, but yeah.
Thanks.
And then, so let's take a look at the review.json. Just, we couldn't see in the PowerPoint there. So it has things like user ID, review ID, a bunch of information, right? So, and note that you're just querying the JSON file here directly,
So
right?
schema is the first level JSON structure.
Yes,
basically.
yes. So the schema is the first level JSON structure it identified. And you can start doing simple queries, right? This is a small business around 40K records. And then I can do, I'm going to get some more complex queries here, but just to introduce the data set here. So again, I think one of the things to note here is drill works with the self-describing data formats, right? It also works with raw data formats like text files where you don't even have metadata. But whenever there is metadata, for example in Parquet, it has the ability to understand that and it can surface it. So just getting some counts, and then you can do kind of standard things. So for example, I want to get what are the top states and cities which has probably the maximum number of businesses listed, right? A simple kind of SQL query. And again, you can do directly just like you would do on a database. Probably I should copy the queries to save time. And then just get the limit 10. Right? So what I'm trying to do here is just simple grouping based on a couple of fields. And again, to just do this, I didn't have to do kind of any data prep or anything. Go ahead.
Did it need to do any sort of indexing to be able to do it that fast?
So it's a small data set, but again, I mean that's part of the performance. The execution engine is designed for interactive queries.
But can you speed it up by sort of prepping it with what it should be expected?
So it doesn't have indexes at this point. Again, the use case is slightly different, right? So you're kind of discovering your data, you're exploring your data.
Okay.
Again, there is a plan to do more. Once you understand the data, can you make it like super fast, right? Caching, indexing, all these things, but it's not there right now.
Question, it's a follow-up to this one. If you're working with underlying Hive database that's partitioned,
Yes.
Is it smart about using the partitions
Yes.
as possible?
Yes, so I'll show a few examples of how partitioning works.
Sure.
It's not just hide, right? Even for the file system, I might be collecting files in a partitioned way, right? So you can point to your directory and you can start doing SQL queries. And it has ability to understand the partitions, it has ability to prune the partitions. Give me a second so I can make some progress. So just want to show a couple of complex data examples as well. So in this particular example, it is a simple correlated subquery, right? So all it is trying to do is give me all the businesses that have review counts which are more than the average review count in that particular state, right? Simple kind of correlated subquery. Again, so some of this syntax that pretty comfortable with, that's something you can use drill with, right? That's the goal of.
You use backfix to quote the column name because it has underscore in it?
Yeah, it has some special characters too. Yeah. Somebody had a question.
I did.
Yeah.
So if you load a 1 terabyte data set on a 10 node Drill cluster, how long does it typically take for it to create hits so we can query?
I don't have numbers to just offer like that, but yeah. So we do, I think just to kind of provide the point on that, right? So we do test up to like 10 terabyte data sets and up to 120, 130 nodes. That's kind of the typical cluster size that you test with. So look, moving on to, I want to show some kind of complex things, right? So here the state, city, they're simple fields that you're able to query. You can do some SQL on it. But querying complex fields is also like equally easy, right? So we saw that business data set has a map type. So it is showing what are the hours during which the business is open, right? On Sunday, what is the time, open time, close time. So basically you can refer to the nested elements just using by dot notation, right? Very simple way to access it. And you can reach into any level of nesting. So in this example, it is trying to say in Las Vegas, what are the businesses that are open before 10 o'clock and they close after 10 o'clock and just rank them by star rating, right? And you can see b.hours.friday and b.hours.friday.open. So you can reach into any level of nesting. You can again do grouping, you can do filters. So you can reach into the nested elements, right? I'll show more complex operations, but this is simple nested query. And the categories item here shows what are the categories under which the business is listed. So it's an array. So a business might be listed in 20 categories. So it's an array. So we'll do more operations on that. But this is just showing how easy it is to kind of get access to the complex data, right?
So is that treating it as a string when it makes that comparison? Does it understand that it's a date, or does it treat it as a string?
You can do date operations.
Yeah.
For this case, I just simplified it,
Okay.
but obviously you can do date comparison operations.
You have to be cast to date.
How does it know that
So
it's a date
drill-
or a number or a real or
Yeah,
all
so
that
the
stuff?
question is, how does it understand, right?
Yeah.
So the JSON itself has few data type support, right? So that are understood by drill, but drill also has extended JSON support. So most of the SQL types, it has, so similar to kind of MongoDB, right? So not just the pure JSON types that come with JSON, but it has extended JSON support, so you can actually recognize some of these additional data types like dates, intervals. So the parser, the JSON reader has capability to understand that.
So one of the things you mentioned was CSV files.
Mhm.
So does it impute real numbers and integers out of
So for JSON, it is a self-describing data format. It has some data type support. There is an extended JSON, so it is more. So it depends on this kind of storage format, right? And in case of text files, basically most of them I believe are either treated as strings or integers. So it just depends on kind of the storage format capability.
Got it.
Right. In case of Parquet, again, it has supports multiple data types, and we actually extended Parquet to support more data types, so it can recognize. It depends on basically kind of the format.
When the nested kind of construct in the Friday
Yeah.
column, okay, gets into a BI tool, which is be string, right?
Yeah, if you just take Friday and put it in BI tool, that will be a string, right? So you want to do more operations on it before you take it to BI tool. So just continuing on the categories example here. So categories is basically an array, right? So I can do simple things like categories. You can basically associate by index, right? So category is 1, category is 2, and I can do things like repeated count on categories, right, from start JSON, let's say like limit 3, something like that. So basically it is trying to say what is the first element in category, what is the second element, what is the total number of elements in the arrays.
But there's no reason to expect that those elements are in any way ordered or arranged, right?
So within a particular, so the question is, do you expect basically the rows that are appearing here?
I guess what I mean is, so that first row has doctors and then health medical.
Yeah.
The second row could have health medical and doctors. Like there's no reason to expect within an array that I'm querying that the array is organized, right? It
No,
doesn't.
you don't. The
it
data
doesn't
in
go
the
through an
array doesn't
alphabetized.
matter.
It doesn't go through an alphabetized, the array, right?
No.
Okay.
So all it is trying to do is, I see that each of the business is associated with 10 categories, for example. It's trying to just list what are the first category, what's the second category, take the literally kind of the array and trying to give you kind of expose the elements. Right, so you can compute what is the array count, so how many categories under which a business is listed. So pretty simple operation. Again, few extensions to work with ANSYS SQL data, right? And so I'll show more interesting examples. So let's go to the previous, the group by thing that we did, which is this, right? So give me all the top states in terms of the number of businesses that are rated in L. So I can do things like, for example, instead of giving me all the businesses, I can say where repeated contains categories is restaurants, right? So give me only the restaurants, give me the top states and cities that have the maximum number of restaurants, right? Instead of all the businesses, just filter it to restaurants. So again, so the operation that we did here is took the categories and we are checking whether this particular array has a string called restaurants, right? If it is true, then that is the row basically. Other rows will be filtered out, only the restaurants will be calculated.
See, in order to work this, I need to have an understanding of the case of the so as an analyst,
That's where we started from select star, right?
Okay, so they have to do that.
I mean,
Is
you
there a
do
base
need to do
trace
select
schema?
star.
No, I was more is there a way to for them to look up in some kind of user interface that they want? They want to try to.
I'll show a few things on that, right? So this is again like the BI technology is in this corner, looking for fixed schemas, and drill is here, trying to provide flexibility. So we have a simple interface, I'll get to that. That's kind of trying to be a bridge for now, but I hope is that the BI tools would have actually native interfaces.
Do you currently have any advanced analytics capabilities, clustering, correlation, regression, or if not, is it the product map flat?
Yeah, so the question is, do you have more advanced kind of analytic functions with
Yeah.
correlations and things like that? So,
Yeah.
so right now there is the syntax is ANSYS SQL 2003. The window functions will be coming in soon. But any of the kind of specific extensions that you want to do, basically you will need to do UDFs, right? So there is ability to do user-defined functions, user-defined scalar as well as aggregate functions.
Yeah.
So you can implement functions.
What language you use to implement to do the UDFs?
Java.
Yeah.
Okay, so I think one thing that might be interesting is I want to continue on the categories. I think a lot of drill features actually can communicate through this. So again, I'm going back to the categories to show another function. So what we saw is how do you get into the arrays, how do you compute the count, how do you do comparisons. So this one is basically again the categories, right? And then one of the interesting functions is probably some of you might be familiar with from kind of related frameworks, but more easier, which is flatten, right? So I can do categories, flatten on categories. Let's say, let's get like, I don't know, 20. So what it is trying to do is basically for each of the elements in the array, it is trying to create a relational representation, right? This is a very simple example, a completely dumbed down example, because the categories is just like a scalar array, right? It's a bunch of strings. But in reality, the actual data sets that we see are, it could be an array of arrays, array of maps containing arrays. So it could be pretty nested format, right? And you can do flatten on top of flatten next to flatten. So you can really kind of navigate and create a relational representation of the data, which you can further take into your BI tools and analyze. So flatten is an extremely kind of useful function, and this is basically you're doing at the query time, right? Not an ETL or any other function. You're basically doing at the query time. You had a question?
No, I was just, it's awesome, but I didn't raise my hand.
Okay.
So actually, since you mentioned that awesome, right? So it's very nice to see when it is running on the local file system, right?
Yeah.
So we really wanted, we'd be interested to see,
Right out.
how it runs on it.
Yeah. So I think two aspects to remember, right? So which is, one is schema free, the whole thing that I'm showing here, working with complex types, being able to discover schema on the fly, that's kind of the core, right? And then there is 60-70% of the development effort which actually goes in making it fast, right? Running it in scale out, and we have seen during beta people using running drill. Though it is intended for interactive purposes, there are people like who process trillions of records, right? Just from a stability standpoint. So yeah.
Your beta sites are, previously running, in Hala and the Hives, or can you comment on that? But, the beta sites that you're referring to.
The beta sites that I'm referring to are they were using previously some of the technology.
Right. And what kind of technologies they were working on?
Yeah, so I think there are two types of use cases that we have commonly seen, right? I was showing the use cases. There is one set of users who are purely looking for speeding up my Hive queries kind of a use case, and that's one use case, right? Which is kind of data warehouse offload kind of a use case, and then but I need interactivity, right? Pure performance focused. And the second type of use case is one of kind of the major telco company is basically they have data coming from cell phone towers, right? And their data is extremely dynamic. Actually, I'm going to show an example of similar data, right? Where even the columns are unknown to them at the query time, right? So they couldn't use any other technology because every other technology requires you to create a schema for the data, but they don't even know the list of columns. So basically, kind of opening up the new use case is another pattern.
So these are the analysts, right? The business analysts have the personas, or
So in the particular example that I mentioned, it's kind of an OEM application that they were building, OEM application. So they would process this kind of sensor data and they would expose it as BI reporting to Tableau and Spotfire. So going back to the flatten example, so I got this flatten example, right? But once I have the relational data, I can basically do all the standard things. So with the same flatten query here, but what I'm trying to do is on top of the data, you're trying to see what are the most common categories under which the business is listed, right? What are the most commonly used categories in a data set. So again, you can see that each of these restaurants and shopping were previously actually in the arrays, right? Now you relationalize them, and now you're trying to do kind of some SQL operations on top of them, right? And this can become extremely complex depending on how much, what kind of data structure you have. But the idea is this is kind of the format that you would take to Tableau, you would take to Spotfire, and you can do like much more further visualizations. So once you think that, okay, there is some interesting insight, you can create tables and views, right? So we talked about the example. So in this example, I'm just combining the data from business, right, and reviews, and I'm getting few elements out of it, some interesting elements from both the data sets, join them, and create a view on top of it. So if I do select con star, so I think one thing to note about drill views, I probably alluded this earlier, but when you create a view, you specify a storage plugin, right? So here I'm saying dfs.temp. So I'm not creating views in Hive Meta Store or any other repository. So my views are actually in file system, right? I'm specifying the view target as file system. So this is a logical view. So if I go to my file system, I created this view in dfs.temp, right? Which is nothing other than my temp directory here. So I can say, let's list like business. So there is a business reviews.view.drill, right? this is just a very decentralized kind of metadata environment. You can of course make it more governed kind of environment by limiting what are the directories in which users create views. So you can always create that kind of environment. But at the same time, as an analyst, I explore some data, I have some finding, I just want to persist. I don't want to go to DBA or somebody to provision a repository for me to persist the metadata, right? So it's all about decentralization. Go ahead.
Are there other serialization formats you can handle, like protocol buffers?
Protobuf is in works. It's not there yet.
I mean, instead of like say a JSON file, like something that's more compact.
So in terms of like just the input format,
Yes. Yeah.
so protobuf storage plugin is not there yet, but there is a lot of interest. And
Okay.
yeah, as I mentioned, building storage formats is extremely easy. Should be able to just build it, join the community and build it. But that particular one is in works.
So the example that you showed, you created a view
Yeah.
in the file system, right?
Yes.
What happens if one creates a view in the Hive workspace? If you call it a workspace.
You cannot create views in Hive workspace. You
Okay.
can only query the data
Okay, so
at this point. Yeah.
views can only be created in the file system workspace. And the view definitions will exist as files.
As just files, metadata files.
Just view definitions, basically.
So I think one thing somebody was asking about create tables, right? So this is an example of basically you can specify, you can also make this like a system format, but you can just specify what is the storage format for this particular create CTAS operation. And here I'm specifying I want to create Parquet file, right? It could be a JSON, it could be a text file. So I'm basically creating a table. So I think one thing to note here again is I'm creating table in DFS TMP, right? So the output of this command is just a Parquet file. There is no Hive metastore, and the Parquet file itself is self-describing, right? Parquet file is self-describing data format, so it can persist the schema information. So if I go and look into my DFS temp directory, so it has this thing called business review table, and so if I go here, right, so there is a Parquet file. I mean, of course, you can partition it, you can do all sorts of things with it, but this is just a Parquet file. I don't have the Parquet tool installed, but if you run kind of Parquet tool to see what the schema in it, it will be the schema that you created the table with, right? So it's not a central schema definition, but it's creating basically self-describing data. So it is consuming self-describing data, it is creating self-describing data formats, basically kind of decentralized metadata model.
I'm just curious about why it's 0_0_0. I'm just curious.
I don't know. Good question.
Partitions.
You can configure partitions, of course, like you can say what are the partitions by which you want to
Because
create
it says
this.
fragment 0_0.
You can actually configure how many files that you want to create.
Okay.
So depending on that, it will create that many files.
See.
Yeah. So again, I don't think we need to do a count star on this, but there is a Parquet table that got created. So just to demonstrate that Drill can actually query the Parquet files, right? Let me go to the actually more interesting stuff here. So that's one. So I think some question here.
That TMP, it's not
Yeah.
a reserved file space or namespace or anything.
There is no reserved namespace.
You did a mapping dfs.tmp to /10.
Yeah, so you can create whatever the workspaces that you want, right? You can also control what are the workspaces that users have access to so that you can limit the directories in which they can create a workspace. So the drill gives you flexibility to completely open up the world, or you can completely restrict depending on kind of the organization requirements.
Is DFS reserved word? The DFS.
Nothing is reserved word. So
Typically DFS is distributed, not a local
yeah, it is
file.
representing that, but you can give it any name. I can say like Neeraja file system. Nothing, yeah, it's all fine. So another quick example before we wrap this up is this check-in data set. So the idea of this data set is it has things like, so the different in this data set is the column names in this are dynamic. So what this data set is saying is I have, this is from public data set, right? So this is saying that 0, 0, 2 elements here. What it says is between how many check-ins have happened on Sunday between basically midnight to 1 o'clock, right? And so the second part of the element represents what day it is, and the first part of the element represents what time the check-in started, right? So if I have, you can read the description probably. So the idea is that if there is a particular time frame at which the check-ins didn't happen, that particular column don't even show up, right? So this is an example of kind of unknown columns. So this is a very kind of classic use case with the Internet of Things sensor kind of data, where you have so many sensors deployed everywhere, you don't have any idea where the data is going to come from, right? So this is kind of dealing with the unknown columns. So I think I need to wrap this up. So what we are going to do here is just to do a select star, so we can see this data better. So this is again, so it is saying between 3 o'clock and 4 o'clock, 4 represents Sunday, Monday, Tuesday, Wednesday. On Wednesday, how many check-ins have happened, right? So that's the representation of the data. So one of the functions that is there in drill is called KVGen. It's like a key value generator. So what it does is, let me show you the output of it. So what it does is it takes each of these elements, which itself, the element name itself is dynamic, so it will convert them into key value pairs, right? So the key is basically kind of the 3, 4, that part of it, and the value is whatever the number of check-ins that you have seen is the value of it, right? Does that make sense?
Your font just got smaller for me. I don't know if you can.
Sorry.
Thanks.
Can you see it?
Yeah, yeah.
I'm sorry, what is the value of this function again? I mean,
So what it is trying to, can you see it? Or, yeah. So what it is